Hey guys, what's up? Eddie Alho here with KISSanalog.com. This is KISS University. We're going to start KISS 102, is it? 101. Let me look. Alright, this is going to be KISS 102. This is a little more explanation about current, voltage, and resistance, and also introducing some more terms, okay? Like energy and power, watts. So, let's do this. Okay guys, welcome to the KISS University. This is KISS U 102. And here are these symbols. EIR. And J for joules and W for watts. And with Ohm's law, okay? So one thing I want to just start with right now is go with the definitions we have. Now we said E is voltage, okay? We use that as the variable, so we say E is for voltage, and then we say, let's say for instance we have 1 volt, so we write it that way, okay? 1 volt. And then if we have current, we say I is equal to, say, 1 amp. And then if we have resistance, we say R is equal to 1 ohm. And that's the omega symbol. Okay, that's the omega symbol. You can look that up, and it's just a Greek symbol to show ohms. So these are the units. It's kind of like when you say distance. You know, you might say the distance for a football field is 100 yards, right? So it's the distance is equal to some number, and y is the yards. Same here. So V is the units, A and omega. Now E, sometimes that's kind of universal. Sometimes people use V for E, but that's kind of how we're starting. The one thing I want to mention is I think I forgot to give credit for the guy who came up with volts, okay? And the volts came from this guy. Here, let me spell his name. It's Alessandro, I think that's how it's pronounced, Volta, okay? And he was an Italian scientist. And here, I'm going to put the years he was born just so you get an idea of when this all started. So that's years that he lived. And he did some other things we'll talk about as well. But okay, so I just wanted to get that in place. So, alright, so let's kind of give some another explanation of how this stuff works. So let's say you have this big tank, okay, and okay, so we have this big tank and it's full of water, okay. So gravity or an air pressure, whatever, puts pressure on this water. So if we were to put, let's say, a pipe in here. So let's say we have this pipe, and we'll put a valve in here, okay? So we just have a valve in here. Well, when this valve is open, water can drain through this pipe. So this pressure is E, okay? And this current flow through here, it's going to be I. Now the size of that pipe restricts how much water flows, right? So it's resistant. So the size of this guy we can say is R. So that's kind of how these things relate. So let me just kind of draw something else here. Let's just say we have a battery, and we have a car battery, okay? these are, I'm just going to say this is the plus terminal and the minus terminal, okay? So it's polarized, right? So when it's polarized, you have a whole bunch of, let's say, electrons here on this plate here for this negative side. And over here you have a bunch of positive guys, a bunch of protons. So they're atoms charged either positively or negatively, okay? If you're to put a wire here, these electrons would want to jump over these atoms over here to join the atom to neutralize them. The atom wants to have equal number of protons and neutrons. Now this chemical reaction will continue that current flow. So now when a battery drains, that's basically when the chemical reaction has stopped generating these electrons, separating the electrons from their atoms and creating plus and minus atoms. So that's when your battery becomes drained. So then you have to charge the chemical back up, so you get negatives here, okay? It's kind of like when this water tank empties out, you got to put more water in it to create more pressure. That pressure is the voltage, and the current flow is all these, let's say, electrons. It's kind of like having a bunch of electrons come here. They're flowing through this pipe, and that's your current flow. So how much current you have is measured in amps. Now you might be kind of wondering, well, how many electrons make 1 amp? So let's just say 1 amp, that's equal to, okay, I'm just gonna make a jump here. I'm gonna say that's equal to 2. Now this is a big number, okay, that's how many electrons. But I kind of made a jump, I said. Really, what this is really equal to is that's that many electrons in 1 second. Alright? Now let's say you just measured that many electrons, but you weren't keeping track of the time. Well, that's really 1 coulomb. One coulomb is equal to this number here. That coulomb is how many electrons you have. Now when they travel through, say, this pipe or if you have a wire here, when you have that many travel through in 1 second, it's measured in amps, and that's kind of how we measure things. All right. Okay, so this thing here, like this, like in this, it's one type of energy that is translated to another type. Over here we have chemical energy translated to electrical energy. Over here we have mechanical energy, changed into what? Well, let's just say, okay, let's put a water wheel here, okay? And we have these paddles on it. Like I said, I'm a terrible drawer, but okay. So we have these paddles, and as the water comes through, it pushes this wheel and gets it spinning. And then this axle of this thing is tied to, let's say, some generator, some motor that creates electrical energy. So that's how mechanical pressure can get turned into electrical energy, kind of like a solar panel or your wind farm. But okay, so now this energy, what we have is we're going to create power, okay? And you measure that in, kind of like up here, you measure that in watts. So let's just say power is equal to 1 watt. So watts are the units, and we have power, okay? Well, now there's another thing that I want to talk to you about, and this is measured in time, kind of like amps or per second. Watts are measured in time too. So really, energy it's measured in joules. And then when you have so many joules per second, you're talking watts. So this is kind of an introduction to this stuff. We'll talk a little bit more about it. Just kind of throwing it out there to get you thinking about this stuff. And then we'll give more explanations and talk more about this, okay?